Hello everyone, and welcome to today's session. I'm excited to have you here as we dive into how to ace your senior developer interview. On this first slide, you'll see the title, Ace Your Senior Developer Interview. The subtitle is Java 17 Interview Prep. Over the next few minutes, we'll go through key strategies, common questions, and tips to help you succeed. So let's get started and make sure you're perfectly prepared for your next big opportunity. Let's start by looking at the modernized switch expressions. These now use arrow syntax to return a value directly, which makes the code much more concise. It also removes the need for fall-through statements that we used to have to manage explicitly, leading to cleaner, more straightforward code. Moving on to pattern matching, this feature simplifies our logic further by allowing inline binding. This means we can handle different cases more elegantly within a single statement, reducing boilerplate and making the code easier to read and less prone to errors. Finally, let's talk about sealed classes. These enable us to restrict which classes can inherit from a particular class, giving us greater control over our class hierarchy. This promotes cleaner, safer code structures by preventing unintended inheritance and making our design intentions clearer. All these features in Java 17 are about making our code more readable, safer, and easier to maintain, which fits right into our overall theme of modernizing Java development. Let's take a closer look at the permits keyword. In sealed classes, this keyword is used to explicitly declare which subclasses are allowed to extend the class. This is a powerful feature because it helps improve maintainability by enforcing design constraints directly at the type level. Essentially, it makes sure that only the subclasses we specify can inherit from a sealed class, which keeps our class hierarchy controlled and predictable. This control is especially useful in large codebases where managing inheritance can become complex. By using permits, we can clearly define the boundaries of our class extensions, ensuring that our code remains safe, understandable, and aligned with the intended design. This ties back to the overall theme of creating robust, maintainable, and clear object-oriented structures. Let's take a closer look at understanding pattern matching for instanceof. Pattern matching actually makes conditional logic much simpler by allowing inline binding. This means we can check the type of an object and simultaneously bind it to a variable in one clean step. As a result, our code becomes not only easier to read, but also safer, because it reduces the chance of errors that come with more complex conditional structures. By using pattern matching, we're streamlining our code, which aligns perfectly with our goal of writing cleaner, safer, and more maintainable programs. This is a key step in modernizing our approach to handling types and conditions in Java. Now, let's talk about how switch expressions in Java have evolved to become more powerful and easier to use. First, they now return values directly, which means less boilerplate code. This change makes our code cleaner and more efficient, especially for modern Java applications where simplicity and performance are key. Next, the streamlined syntax of switch expressions helps us write shorter, clearer code. This reduces the mental effort needed to understand and maintain it, leading to faster development cycles. And finally, the new arrow syntax really boosts readability. Instead of verbose case structures, we can now express our intent more clearly and concisely. This makes our code not just easier to write, but also easier to understand at a glance. All these improvements align perfectly with our goal of writing better, more maintainable Java code. Now, let's take a closer look at exploring the new Random Generator API. This update offers faster generation with lower computational overhead, which means you can get your random numbers more quickly and efficiently. It's all about improving performance so that your applications run smoother and more responsively. One of the key features is that it provides a single API for seamless RNG functionality. This simplifies the process, letting you access all the randomness features you need without juggling multiple tools or interfaces. It's designed to be intuitive and easy to integrate. Additionally, the new API uses enhanced algorithms to deliver improved randomness quality. This means the numbers generated are more unpredictable and reliable, which is crucial for applications requiring high security or fairness. Overall, this new API ties into our broader goal of making random number generation faster, more efficient, and more trustworthy, helping you build better, more secure systems. Migrating to Java 17 brings some notable challenges that we need to be aware of. First, blocked internal APIs can really hinder our efforts, especially when trying to integrate legacy code that relies on those internal methods. It's something we'll need to carefully navigate. Next, reflection issues can complicate dynamic programming since Java 17 enforces stricter access controls, which might break some of our existing reflection-based code. Then there are library breaks. Some third-party libraries may no longer be compatible, so dependency management becomes more critical than ever. Lastly, the module system itself requires a thorough understanding and careful planning. Proper modularization can improve our architecture, but rushing into it without full knowledge could cause more hurdles down the line. Overall, these challenges are manageable, but they highlight the importance of a strategic approach to ensure a smooth migration. Now, let's look at how improved algorithms are making a real difference in memory management. These enhancements allow garbage collection to work more efficiently, which means the system can reclaim memory faster and more effectively. This leads to smoother performance overall. One of the most noticeable benefits is a significant reduction in application launch times. When garbage collection is optimized, applications start up quicker because less time is spent managing memory during the initial load. All of these improvements tie back to our overall goal of enhancing performance in Java 17. By refining how memory is managed, we're not just making individual features better. We're creating a more responsive, efficient environment for developers and users alike. Now, let's talk about how modern fintech applications use sealed interfaces for payment processing. Essentially, a sealed interface helps to safely encapsulate all payment types, meaning each payment method is protected and isolated from others. This approach enhances security because it prevents unintended interactions between different payment implementations. By leveraging pattern matching and switch expressions, developers can write cleaner code that's easier to maintain. These features allow us to handle various payment types explicitly and efficiently, reducing the chances of bugs slipping through. Most importantly, this method promotes a seamless transaction experience for users. When our code is more robust and secure, users can trust that their payments are processed smoothly and safely. Overall, using sealed interfaces in this way aligns perfectly with our goal of creating secure, reliable, and user-friendly fintech applications.